We see wind turbines with just 3 blades installed in wind farms, and some are relatively small. But wouldn't adding more blades to the turbine make it generate more energy, or wouldn't making it bigger make better use? Today I'm going to talk about why wind turbines are the size they are, and why they only have 3 propeller blades. Hey engineering lovers, we recently received this very interesting comment. I would like to know why the turbine blades are so thin and only have 3. If they were thicker or had more blades, wouldn't it generate more? I always had this doubt. Well, first I would like to thank Janio, who asked this question, and say that if you also have a question like this, leave it here in the comments. This is very interesting so that we can create our content aimed at your questions and have direct contact with you. But here we go. People have been harnessing the power of the wind for thousands of years, and the earliest recorded evidence can be seen over 1,000 years ago in Persia. But these machines have evolved from simple devices used to crush grain and pump water, to gigantic shovels that generate enough energy to power entire cities. Traditional wind turbines come in many shapes and designs, but they have all given way to a fairly consistent 3-blade design. But why do these wind turbines only have 3 blades? We can imagine each blade as a wrench tightening a nut. If we increase the length of the wrench, we can generate more torque, because it is exactly this force that causes a rotation. Likewise, if we add a second key, we can apply even more force. This same principle applies to wind turbines as well. So naturally you might think, why not add more blades and make them longer? The largest wind turbine to date is Mingyang Smart Energy, with a total diameter of 260 meters. It has a design with 3 blades, each of which has a total length of 123 meters, and despite being made with carbon fibers, each blade weighs around 54 tons. To give you an idea, the tip of the blade can reach speeds approaching 70% of the speed of sound. But why not manufacture the same turbine with more or fewer blades? Let's compare our standard 3-blade design to other 2- and 4-blade turbine models, assuming they have the same blade design. We know that every engineering work takes into account a cost-benefit ratio, and there is an ideal point throughout the useful life of the wind turbine. So if we consider the production cost of wind turbines throughout their useful life, there will be a time until the revenue generated by the turbine pays for production cost, and only then does it generate profit itself. If we add another blade to the wind turbine, we increase the production cost and consequently reduce profits. This way, we can eliminate the 4-blade design, where what makes it unfeasible is the production cost itself. This leaves us with 2- and 3-blade designs. The interesting thing is that the 2-blade design can actually match the performance of a 3-blade design. According to the book Wind Energy Handbook, to be able to get close to the performance of a turbine with 3 blades, we would either need to increase the length of the core by 50% or increase the rotation speed of the turbine by 22.5%. For you to understand, in the design of a wind blade, the chord is the distance between the radius of curvature from the leading edge to the trailing edge. Just think with me. If I have to increase 50% in each blade of a 2-bladed turbine to have the same performance as a 3-bladed turbine, adding 50% of one with 50% of the other would be the same as adding 100% in the set. In other words, it would be the same as adding another wind blade to the turbine, so there would not be much advantage in increasing the chord length. As I also said, we could increase the rotation speed of the blade by 22.5%, and it would need to have a higher rotation speed. Turbines with 2 blades will spin faster in the same wind, due to the reduced drag they experience. But the fact that it rotates with greater speed, it's not exactly a positive point, but something bad for the project. But why is it bad? If it is spinning faster, it will be able to produce more energy, right? Well, the design of the wind turbine takes into account several factors during its design, and some of the important points are vibration, centripetal force, and noise. Having a wind turbine spinning at a higher speed can end up generating greater vibration throughout the entire assembly. This means that with higher speeds, we can introduce more vibration to the assembly and consequently require stronger materials. But it's not just the vibration, but also the centripetal force. We know that if we tie an item to the end of a rope and turn it, we will generate a centripetal force that pulls it towards the center of the turning point. In other words, this force ends up generating a traction force on the rope to keep this item in the spinning condition, and the higher the spinning speed, the greater the centripetal force. And the same happens with wind turbines. If the rotation speed increases, we will increase the centripetal force, meaning that both the blade and the blade's connections with the rotation axis need to be much more reinforced to withstand this force. And guess what? This increases the cost. And finally, we have the noise. For those who don't live near wind turbines, you may think that this is far from being a problem, but believe me, it is a real problem. A faster spinning blade will generate more noise. This is what a turbine sounds like up close. We already made a video talking about the disadvantages of wind turbines, and noise is one of them. I'll leave a card for this video at the end of this one. At the end of this analysis, we arrived at a sweet spot with a 3-blade design. They can generate more energy at slower speeds than a 2-bladed one, and have a better cost-benefit ratio compared to the 4-bladed design. And that's why we see wind turbines with only 3 blades. Its size has a direct relationship with the production cost. The blades are designed to be an optimal size that maximizes the amount of energy captured from the wind, considering the strength of the material and the structural limits of the tower. If the blades were larger, the extra weight could overload the turbine components and increase the risk of mechanical failure. Furthermore, more robust towers and much more expensive foundations would also be required, which increases construction and maintenance costs. That saying that says 1 is little, 2 is good, 3 is too much does not apply to wind turbines. And perhaps it is better to create a new saying where 2 is bad, 3 is ideal, and 4 is too expensive. If you've come this far and liked the video, take the opportunity to subscribe. If you're not already subscribed, leave your like and turn on the notification bell. If you find our content interesting, consider becoming a member to help us continue producing content here at Platform and be remembered in our videos. And if you are looking for professional growth, I will leave a link below where you will find several opportunities to develop various skills that will make a difference in both your personal and professional life. So, did you know why wind turbines have 3 blades? Have you ever imagined having a version to be installed on the roof of your house to generate energy? Have you ever seen a turbine like this up close? Leave it here in the comments and I want to know.